Okay, welcome to section 1.2. We're going to be talking about the equation of a line, specifically the equation of a line of a direct linear relation. Now, previously we know that a direct linear relation, let me just change that line again here. We know that a direct linear relation passes through the origin, point 0, 0. That is the definition of a direct linear relation. And when we're working with equations of a direct linear relation, what we need to start out with, every single equation starts out with the slope of a line. Now, we know from the formula that slope is equal to y2 minus y1 over x2 minus x1. That is the slope formula. Now, if we know that the line goes to the origin 0 and 0, that's one of our coordinates, we know that y1 and x1, if we use that as our second coordinate here, we know that that is a 0. So we could expand this and we could say that the slope is, we could say y2 minus 0 over x2 minus 0. Now anything minus 0, it's just itself, so we could expand that just to say the slope is just equal to y over x, because this y minus 0 is y, x minus 0 is x. Now when we're talking about equations of lines, we're talking about writing down a formula that always begins with y is equal to something. All right, there's different variations of the equation of a line, and they all start out with y is equal to something. Well, if I go back to this formula right here, and I want to have y is equal to something, how do I do that? Well, m is the same as m over 1, and when I've got an equality like this and I want y is equal to, what we need to do is we need to cross multiply. We've got y times 1 is y is equal to m times x. So what I can rewrite this formula here by cross multiplying is I can say that y is equal to mx, or y is equal to slope times x. This formula right here, it can be used for any direct linear relation to calculate the slope of one point, x or y on the graph, the y value of a given value if the slope is known, or you can use it to calculate the x value for any given y value if the slope is known. Okay, so what we're going to do is we're going to take this formula and we're going to apply it to information from a table, and we're going to see if we can graph it. Okay, so supposing I had the equation, I could say y is equal to 6x. Okay, y is equal to 6x. Well, we know that m always stands for the slope, so we can say that the slope of this line, just by looking at it, is 6. Because if we follow the formula here, m is 6, so we know the slope is 6. Now we know that this is a linear relation. Okay, it means it's going to be a straight line, but what does it look like? Well, first thing we need to do is we need to create a table of values, because we want to have a series of points that we can graph, specifically x and y coordinates, x and y pairs. Okay, let's put this box up here, and this is the equation, y is equal to 6x. Now we know this is going to pass through the origin. It is a direct linear relation. From this right here, okay, because we know that it's we've got one coordinate 0 and 0, so that's why we end up with this equation right here. So we know it's already going to go through the origin. Okay, so I'm just going to put x here and I'm going to put y here. So I'm just going to draw some rows here. I like to draw at least 5. 1, 2, 3, 4, 5. That gives me enough points to be able to get a decent graph. So if I was to put x is 0, okay, in other words, if x is 0, I substitute x into this equation right here. Y is equal to 6x. Well, 6 times 0 is 0. So I know that y is going to be 0. So I know that it is a direct linear relation because it's going to go through the origin 0, 0. Okay, so let's give some y values here, or x values here. Let's put in, well, let's make it simple. Let's do 1, 2, 3, and 4. So for each x value right here, I'm going to substitute it into this equation and I'm going to calculate y. So 1 times 6, if I substitute 1 for x, I get 1 times 6 is 6, so y is going to equal to 6. 2 in for x, 2 times 6 is 12. Substitute 3 in for x, 3 times 6 is 18. And substitute 4 in for x, 4 times 6 is 24. Now another way I can tell, just prove that this is a linear relation, is that if I have a constant change between each of the variables on both sides, I know it's going to be a straight line. So this is always going to be a 1, 1, 1, and 1, so I know that's a constant change. And this is 0 to 6 is 6, 6 to 12 is 6, 12 to 18 is 6, and 18 to 24 is 6. So this is constant, so I know I'm going to end up with a straight line. So now it's just a matter of graphing this. So I'll graph it. It's my y. Here's my x. There's 0. On my x column, I'm going up to 4. So I'll make it easier on myself, and I'll separate the numbers by a little bit. And I know I'm going up to 24 on the y. So I'll probably go, let's say there's 25, and maybe I'll go by 5s. So there's 5, 10, 15, 20, and 25. So let's go and let's plot this. When x is 0, y is 0. So here's my first point, right through the origin. When x is 1, y is 6. 1 and 6 is there. When x is 2, y is 12. So 2 and 12, right there. 3 and 18, about there. And 4 and 24, oh, about there. And then I can connect all these points with a straight line. Okay, so that is how you would graph this particular equation of y equals 6x. When you've got y, the formula y equals mx, you know that it automatically will be a direct linear relation, okay, and that it will be going through the origin because of this formula right here, okay, because our one of the points on there is 0, 0, so it's just going to be y equals mx. We create a table of values, write the formula up here, put an x and a y column, put in some x values, calculate using this formula here what the y values would be, and then just graph it on a graph. Okay, so the questions that you want to do in your workbook are from page 32 to page 40, and that is just graphing some examples of this formula y equals mx, which is a direct linear relation, which means it's going to be going through the origin. It will be going through the origin. And you want to complete the examples up to page 40. Okay? Good luck.